The automatic transmission is perhaps the most complicated component in an automobile. It combines electrical and mechanical systems, hydraulics and computer processors to smoothly shift through the gear ratios and transfer engine power to the drive wheels. There are three basic types of automatic transmissions: the dual clutch transmission, or DCT, the step-type transmission, and the continuously variable transmission, or CVT. This video will explain the basic operations of a CVT and why the right automatic transmission fluid is critical to its proper functioning and longevity, and to your driving safety. There are three main components that are unique to the CVT: two pulleys, also called variators, and a push belt or chain that connects them. We'll focus on the push belt design. One pulley is connected to the input shaft from the engine, typically using a traditional torque converter like those on step-type transmissions. The other pulley is connected to the car's drive shaft. Each pulley has two conical surfaces facing inward. One surface is fixed and the other is hydraulically controlled to move in or out along the central shaft. Changing the distance between these surfaces also changes the radius on which the belt rides, providing an infinite number of possible gear ratios. The Transmission Control Module, or TCM, is the brain of the transmission. It communicates with the Engine Control Module to analyze changes in operating conditions, then fine-tunes the CVT's gear ratio to operate with maximum efficiency. When the engine is idling, the CVT rests in low gear. As the vehicle accelerates and more load is applied, the TCM recognizes this change and adjusts the pulley positions accordingly. And this is a smart system. It can even learn from previous driving conditions. There's one component of the entire CVT system that's critical to all the parts working together properly. It's the Continuously Variable Transmission Fluid, or CVTF. The CVTF is a precise blend of different chemicals because it does a lot of different jobs. It works as a hydraulic fluid in the torque converter and oil pump, and also in the valve body, which actuates the changes in pulley position to change gears. And while the fluid reduces friction in the pumps, gears, and bearings, it actually increases friction between the push belt and the pulleys. The CVTF has to dissipate heat away from metal components and protect them from wear and corrosion due to high temperatures. It must be extremely tough and durable, since the prolonged metal-to-metal contact tends to break down the fluid quickly. Finally, CVTF has to be compatible with all the electronics and protect against unwanted conductivity between electronic parts. Modern CVTFs include friction modifiers, special agents for anti-wear and anti-corrosion, and chemicals to enhance high heat performance and maintain a specific viscosity. So using the right ATF is critical to the performance and long life of a CVT transmission. A CVT has particular needs created by the steel-on-steel contact between the belt and pulleys. So a CVTF is very different from an ATF used in conventional step-type or DCT transmissions. Using the wrong type of transmission fluid can cause excessive wear in the belt or chain, pumps, gears, and bearings. At best, you'll risk increased noise, vibration, and harshness. At worst, you can experience slippage in the transmission, and a single slip event can lead to catastrophic failure of the entire transmission and disable the vehicle altogether. The automatic transmission is one of the most complex components in any vehicle, and it's also one of the most expensive. So follow the manufacturer's suggested service intervals and use only quality parts and the recommended CVTF to maintain your transmission. You'll be glad you did.